Assalamualaikum and good day. Today, we would like to explain about chapter 8, discussing about the piping, ducts, and the insulation system. This one is included in the component system in the HVAC. Even as we know, the aircon system, not all type of aircon include the piping or duct system. Some is avoid this condition because consider to very small of air conditioning system. In piping or include of duct system in the HVAC is mean have a big size of the HVAC system. So that's why some should be designed and proper designing include all the equipment or instrument in the piping and the duct system. Okay, we go to the piping system. The first, maybe we try to understand how to piping selecting in the duct system or the pipe in the HVAC system. The first one, maybe we try to find out the properties of fluid that will be carrying in the piping system, and then what temperature include or in the system process, is it higher or lower, and then how about the pressure, is higher or lower, also exposure to oxidation or corrosion because of type of the maybe fluid itself or the environment system, and then the cause availability, and the last is limitation by codes and regulation. Okay, as we know, in the material itself of piping, in the low carbon black steel pipe and copper tubes, this is common use in the HVAC system that standardized by ESTM, short form by American Society of Testing Material, is the most commonly used material for piping in the hydraulic system, where oxidation and corrosion are not severe. Okay, we go based on the material system. We separate by the black steel pipe and the copper pipe. So where the copper pipe will use, and then where the black steel pipe will be implemented in the HVAC system. So maybe in the HVAC system, under the black steel pipe, we will consider by schedule from 20 until the 80 of the schedule. Schedule itself is referred to the thickness of wall or the pipe itself. So if you want to the higher of thickness, so the schedule number should be higher. If you are lower, for example 20 or less than 20, like 10, it means with a certain diameter, outside diameter of the piping, maybe has the thickness is thin in the lower number, but have the higher thickness, maybe we will implement in the higher pressure, we will use the higher number of schedule. Then usually schedule we will implement in the application is 40. Yeah. So we go to the copper pipe. Yeah. The wall thickness of copper tubing is specified by lettering system type K, L, N, DWV is minta drain with ventilation, this one. So different type with the black steel in the selection tap system. So what is the K use is the thickest wall is used with the high pressure and refrigerant. And the type L, intermediate thickness wall, usually required for hydronic system piping. And type M is used for low pressure plumbing. So it means K is thicker to the lower thickness, from the higher of thickness to the lower. So K is considered higher of thickness. The outside diameter is the same for any size for all three types. Inside diameter change, therefore pressure drop is greatest for type K. So actually, the outside diameter size is considered fixed by selection of K or LM is similar of outside size, but when we try to select within K to M, it means inside diameter is changed. So if diameter is higher, it means thickness is lower. So inside diameter lower, it means the thickness is lower. So we go to type drainage, and vent is used drainage by using ASTM B306. This one is for the copper pipe, because we maybe will try to implement in the corrosive environment. We will use copper pipe. So what are the advantages and disadvantages from both material? The steel has stronger material and doesn't damage easily, and uses a larger piping because more strong material and cheap. But in the copper, less frictional resistance, then still resulting the possibility of smaller pump and less power consumption because of lower resistance. And then not subject to the oxidation and sealing to the same extent as steel. So as we know, copper is resistant to the corrosion condition. So disadvantage from the piping, labor cost of smaller size is more expensive than copper. But in the copper, disadvantages is material is more expensive than steel. Okay, this one is considered to the how to selection commercialized size in the steel pipe and also in the copper type specification. So this one in the table 9.1 is for steel pipe, 9.2 is for copper tubing in the L type. Okay. Okay, we go to example 9.1. Okay, we can see here. But before that, I introduced what the content in the table 9. Okay, we have the part size, schedule, outside diameter, so inside diameter, wall thickness, and weight in the British unit, and also last is the volume that can be carried by the pipe. Okay, we go first. How to check in the size in the half inch. So if we refer to schedule 40 in the half inch, so it means the outside diameter is 0.8 something, and that inside is 0.6 something, and the thickness automatically within this inside and outside. So the weight also report here in the table. Okay, in the table 9.2, we don't have a schedule properties, but informed by the L type. Okay, it's mean the medium, medium thickness. So 3 over to 8 inch, and outside diameter is ½ inch, and so on. So inform all specification of pipe, both steel and the copper. Okay, now we go to example 9. We have a 60 feet long of pipe with a 5 inch of, this means 5 inch of pipe size, schedule 40 here. And chill water steel pipe is to be hung horizontally from the floor slab above. The structural engineer asked the HVAC contractor to determine how much extra weight from the floor will have to carry. So the question is, the weight with the 60 feet long of pipe with the size of 5 inch schedule in the schedule 40 with contain the water, so the chill water. So we can refer the table here. So the table refer to the steel, because the question is mentioned to the used material of steel pipe. So if we go to the size in the 5, schedule 40, so contain a weight of pipe itself, 14, yeah, 14.9 pound per feet. And the water is mean the density water in the British or British unit, 8.3 pounds per gallon. So because of content, the pipe can carry in the 1 feet weight, density is 1.039. So just times 2 density every feet. So the water weight every feet is 8.6 pound per feet. And how about the 60 feet long? So we can sum the weight of pipe in the 60 of length, and then also water carry inside in the 60 feet of length. So the total weight is 1,392 pounds. Okay, this one is of weight. Okay, actually in the piping system, actually have several equipment or instrument actually in the piping system. Involve or include fitting, joining. So now we go to how to understand type of fitting and joining in the piping system. Okay, screw fitting for steel piping are generally made of cast or malleable iron for typically handling system fitting with the 125 pressure square inch pressure rotating are usually indicated. For in duct, the system pressure should be checked. So actually, instrument when we joining the piping, include the screw, include the other instrument like flange, fitting, welding, anything. So we include inside the piping system. About the screw we need for joining, because we don't produce in long piping. So when we need to add piping, we try to joining the piping by certain method. Screw, fitting, and also welding. So you can read by yourself what is the welding, this one type of pipe fitting. We have the elbow with the 90-degree, and then the T coupling fitted with the thread joining, union, and so on. This one is under instrument of piping. Okay, now under the joining system, we have soldering or sweating, brazing, and flaring. So what is different between them? So we go first, soldering. So soldering, we need other material to melt, to join within two material. So the temperature process is within 400 degree Fahrenheit until to 1000. More than this one, we call the brazing. More than 1000 degree Fahrenheit, we call the brazing. Another method is flaring. This one is typically for the copper joining. Okay, this one the example how to make the flaring, flaring system, joining in the copper tube system. Okay, another instrument in the piping system is strainers. So what is the strainer? Strainers are used to remove solid particle from the circulating system. So we try to filter the unwanted particle inside of the piping. This one is will be make the flow inside of piping unsmooth, unsmooth. So we need to remove this particle. So by using strainers. So we can see one example of strainer in the figure 9.4 is type Y, Y type strainer. So the inside below we put the perforated plated inside here. So the unwanted particle will be stuck here in the Y piping system strainer. And then other type of instrument is part expansion and anchoring. So provide for expansion whether desirable, provide proper anchoring of piping where expansion is undesirable. So sometimes we got the high temperature suddenly change the temperature or pressure sometimes because of fluctuation of condition operation, such as a restarting of the process. So maybe the pressure will increase suddenly. So the expansion of the looping we can use to reduce, to absorb the strange expansion of the piping. All temperature difference in the process. Sometimes the piping on the outside, on the ground, that one is open to the sun influence, so will be increase the temperature. So the piping from the because of the from the metal will be expand. So to reduce to absorb this expansion, we can use pipe expansion by offset. Okay, the first figure using the offset, and then we see for loops method. Okay, using expansion loop or offset, allow the pipe to bend at the loop or offset. Those accommodation the expansion. So the bending itself results in stresses on the part. So the size of the loop or offset must be adequate and depend on the length, such material and temperature change. Okay. Okay. Other instrument in piping, expansion joining. So as we know, as mentioned before, we don't have the long pipe in the market. So what we do, we just joining within the piping. So sometimes we use flange, sometimes we use the T junction or sometimes elbow junction. So this one joining by flange, flange system. This one. Okay, it's one figure differentiate within the loop and offset system. Okay, to reduce bending of the piping because of weight itself can act as the loading into the piping system. So to avoid this, we try to develop anchor within the piping. So we try to calculate where the distance can make the higher bending. So we try to support by anchor. So the cable should not be used as anchoring point. Anchoring connection must be made so that any force is transmitted to part of building structure adequate to take the force. Sometimes we develop on the ground on the building. And then we try also develop anchor, offset. You can see from the figure to reduce expansion system in the piping system. Sorry. Okay, this one type of the anchoring we can apply by vertical piping anchor and also horizontal piping. Okay, the upper figure mentioned in the vertical system. And then you can see the below is horizontal piping. Okay, actually when the process in the transfer fluid inside the piping, in the process because of high velocity and also pressure will build the vibration in the piping itself. So to absorb the vibration, we call a vibration isolator. The isolated support may be made from cork, rubber, or steel spring. One more of following procedure may be used when vibration are transmitted to the piping. So use of isolation hanger using an isolation material like cork trail between the cradle and pipe may be sometimes be adequate for more serious problems. Spring hanger can be used. Sometimes they put within the piping. So this material will absorb vibration of piping. So we will locate it within the support and the piping. Use flexible pipe connection to the troublesome machinery. However, flexible connection tend to become inflexible to high pressure. So sometimes we use a flexible connection like fiber. So within the piping, we construct or put the flexible material within the piping. So maybe when the when the piping vibrate, will absorb directly by the material. Thermal insulation, yes. In the HVAC system, you should be maintain the temperature during the transfer or transport the fluid until to area wanted. So the thermal insulator to reduce energy waste and possible increase size of heating or refrigeration equipment. So we can save energy from this insulating. To reduce incorrect distribution of heat, uninsulated piping may result in the water being unsatisfactory temperature. Okay, a good insulation should have following characteristic: low thermal conductivity. Low thermal conductivity is mean the material is a insulator, so cannot transfer within to one side to the other side. So the lower thermal conductivity, so cannot transport the thermal. Non-combustible, of course, not subjected to the deterioration or rot, and adequate strength. So it should be not the destroyed the material. By high temperature, the material is maintained with the dead properties or like the physically, like initial physically, and also the mechanical performance or the physical, so cannot be destroyed. Pipe insulation may be made from natural materials such as wool, felt, rock, or glass fiber, cork, and rubber. Some general practice for installing the piping system will be listed here. Piping should be generally be parallel to building wall. Direction change should be minimized to reduce the number of fitting. So when we design, we try to minimize by using the instrument. The instrument actually is very costly, so we try to minimize by using costly. So we try to calculate the cost. And the installation should be provide simple access to and maintenance of equipment, for example, to run piping in front of control panel. So when we try to design the piping system, so we include how to maintain it. So maybe we try to make easy to maintain it. The piping must not interfere with the installation of other trade. This must be checked with the plan of duct lighting and so on. So please refer to number 5. It's very important because when we try to develop piping in the building, we don't please avoid to cross to another instrument or equipment. The piping location must be non-effect to building function, so we not reduce the performance of building. Install horizontal piping with a slight pitch and take all branch connection from the top so that any untrapped air will flow to high point. Provide air vents device at all high point. So this one you can read by yourself. Okay, now we go to other instrument of piping, valves. So what the valve function? So stopping and starting flow, reduce or increase of flow, controlling the direction of flow. So this one is a function of valve. So we go first of type is valve. Pressure regulating valve or PRV, where water pressure may exceed safe limit for equipment. A pressure regulation valve is used. So this valve limit the discharge pressure to pressure value. So we can control the pressure and the volume by using the pressure regulation valve. Then another pressure relief valve are not the same as a PRV. A relief valve open when the valve inlet pressure exceeds a pressure value. Use a safety device to relieve excess pressure in boiler and other equipment. So as a pressure relief valve, if the pressure cross the limit or the maximum, so the pressure relief valve will open. Okay, this one is the body of valve. You can see this is like the casing of the valve with the inlet or let, and then also the top one is for controlling. This one for the top one of the body of the valve. This one inside this plug inside of the body of valve. Also, we have a seat or ring inside to avoid the leakage, leaking from the piping system or valve system. And then valve stem. This will be open the valve or close the valve. A gasket packing, we need gasket in the joining between the pipe and the valve. And spring is so we need to give the pressure to the what we call in the valve, like the to allow the valve open or close. This one gate valve, construction of gate valve. This one is for open and close technique. Just rotate the handle. Globe. Okay, this one globe also same. We can open. This one, this type is a common. Maybe we can see every piping system commonly used. Valve material. Okay, valve material for hydraulic service header or bronze valve are iron body with bronze part are generally used. For many applications, valve with 125 pressure square inch rating are suitable but should be checked before selection. At extremely high pressure, steel valve may be required. Valves are available with the screw flange or welded head. Okay, based on the selection, we can select based on the gear valve should be used only for stopping flow. If we want to do only for stopping, please using stopping type, not for throttling. Regulating throttling flow can be accomplished with globe, angle, plug, needle, or butterfly valve. These are regulating. You can choose this one. For large diameter butterfly valve have become popular in the hydraulic system because they cost considerably less than globe valve. However, they should not be used where extremely tight, sharp, off, or very close regulation is required. Okay, please consider this condition. if you want to select the valve selection. This one actually is for expansion valve, operating same like the external expansion valve. Expansion valve. So if you have high pressure, this one of the sensor, the high pressure will push the diaphragm to open the flow. Okay, now we go to duct system. So function of duct, the function of duct is to transmit the air from the air handling unit to the space to be air conditioned. The conditioned air must be properly distributed to provide comfort zone condition. Duct system are also used to bring cool or warm air to the proper distribution. And then duct isolation, carrying hot or cold certain materials, lighting and so on. This one is type of the material for the duct system. This one classification of duct. According to the velocity, low velocity, higher velocity of duct system. So up to 750 meter per minute, consider to higher. So low pressure, high pressure, according to type air, supply air duct, return air duct, and fresh air duct. So we separate by system, by supply, return, and the fresh air duct system. This one general rule for duct design should be conveyor as directly sudden change in direction, so should be fixed. Diverging section should be gradually angle or divergent less than 20 degree. Aspect ratio should be follow this one. This one a factor design of duct. So if you need the area, so be calculate by height and the width of the duct. If the in circle should be area of circle. Material, GI sheet, aluminum, stainless steel, fiberglass, GFRP. GFRP is graphite, fiber reinforced polymer. Graphite, fiber reinforced polymer. And dynamic loose duct, how to measure the losses. So bend, elbow, sudden change, and so on. And duct design method based on two types, velocity reduction and equal pressure loss. So when we design the duct, we measure the velocity of the air supply and also pressure. This is enough to supply to the certain area. So we design based on this. So if we design velocity reduction, velocity duct assume data decrease as the flow proceed. So we try to measure what the velocity until to the point area. And then by pressure also, we try to measure what the pressure should be supplied in the point. Okay, that's all for class today. So before that, I try to remind you, please make the summary from this class to consider your attendance. Please complete your summary within 1 week. Thank you. That's all. Maybe we will meet in the next class. Thank you. Assalamualaikum and good day all.